So, like I said, I am recording this. I'm going to explain this last question, but I'm going to introduce a shortcut method. What's the very first type of factoring that we should try? Very first type of factoring we learned? GCF. So what is the GCF on number 15? You pull out a 3, right? And you can't pull out any x's, so just a 3. If you do pull out a 3, you're going to end up with a 6x squared. You're going to end up with a plus 5x, and you're going to end up with a minus 4. Yay? Okay. Now, when you look at the inside of the parentheses, we have a blue quadratic trinomial right there. So we're going to ignore the 3 on the outside for a bit, and we're going to attempt to factor this blue quadratic trinomial. And you have all these factoring tools. You got to ask yourself, is this a perfect square? Is that a perfect square? They're not both perfect squares, so you can't use the square roots. You can't use that shortcut, or you can't use that tool. But we do have an a value that's 6, not 1, which means we have to go through that multi-step process that we learned yesterday. You guys remember that? First step is to do a times c, where a is 6 and c is negative 4. Again, we're ignoring the outside 3. We're just focusing in on the blue quadratic trinomial. So what is a times c? That is negative 24. And then step 2 is to make a list. Think of the multiples of that negative 24. So negative 1 times 24. And then after negative 1, we're going to try negative 2. Negative 2 times what gets us 24? That'd be a 12. Negative 3 times something give us negative 24? 8. Negative 4 times something? 6. Negative 5? Nope. Okay, so those are all the possible ways of multiplying numbers together to give you that answer, negative 24. Besides changing signs, but we'll change signs only if it's necessary. The idea is which of these pair of numbers combines, like as in add them, that'll give you the b value, which is 5. So 24 minus 1 is 23. That's not a 23, it's a 5. We want a 5. 12 take away 2 is 10. That's not a 10. 8 take away 3 is 5. That is a 5. And we don't have to change any signs. So this is the pair of numbers that I want. Now, normally, according to yesterday's lesson, I would say to rewrite your quadratic trinomial, 6x squared, but instead of the middle term being positive 5x, I want you to replace it with these two numbers being a negative 3x and a positive 8x. And of course, you continue writing the minus 4 at the very end. You just write it there. Changing your 3-term expression to a 4-term expression. Why the heck would we want 4 terms instead of 3 terms? So we could factor by grouping, right? Okay, and we all know how to do that, right? But let me stop right there. We'll pause it right here, and we'll get back to this question right now. I want to show you a shortcut, and the shortcut is this. So steps 1 and 2 are the same. Step 1, multiply a times c, get an answer. Step 2, think of the multiples of that answer that combine together to give you b. Make a list. We already did those 2 steps. Now, instead of writing your trinomial into a 4-term polynomial so you could factor by grouping, we're going to jump to this step 3. Now, what is step 3? Write your factored form answer in this format. Parenthesis ax with the number here, parenthesis ax with the number there. We're going to leave blank spots. And then you plug in your pair of numbers from step 2. That's what it says here, from step 2. Plug in the pair of numbers from step 2 right in here. And then step 4, magically reduce. Think of the GCF of each binomial if possible. So I know this sounds really weird, but it's going to be ridiculously faster than factoring by grouping. So check this out. Instead of, whoops, move this to the side. Instead of going with this route of changing it to 4 terms, I'm going to do their step 3, or the shortcut step 3, which is to do parenthesis, 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 ax, ax, a number here, and a number there. Now, what is ax? Well, our a value of the blue one that we're working on is 6. So I'm going to put a 6 with an x. A 6 with an x. And what numbers are we talking about right here? The numbers from step 2. The negative 3 and the positive 8 go right here. Negative 3, positive 8. Let me actually draw that. Negative 3 is going to go right there. Positive 8 is going to go right there. So minus 3 plus 8. So this is a shortcut. right? Instead of doing the 4 terms and factoring by grouping, which is another 3 steps on its own, you plug it into this format, and that almost looks like our answer, but we know that this is for sure wrong. Why do I know it's wrong? Because if I distributed 6x times 6x, that would give us 36x squared, not 6x squared. So this is almost our final answer. This is where I call it the 4th magical step. 4, magic. What is the magic? You're going to magically reduce each binomial by its greatest factor. Okay, it's kind of like pulling out a GCF, but you don't really pull out the GCF. It's kind of like reducing a fraction, but it's not even really a fraction. It's just in our head, we are going to divide the 6 and the 3. We're going to divide both of them by 3. So I want to put in a little cloud because you're not actually writing it down. It's just in your head. 6x divided by 3 is 2x, and 3 divided by 3 is 1 with the minus sign. And the other one, the 6x and the 8, what could I reduce those two by? By 2, right? You're going to magically divide both of those by 2. I put that in a cloud because you don't actually write it. You just divide it in your head. 6 divided by 2 is 3 with an x, and 8 divided by 2 is 4, and it's positive. Believe it or not, we're done. That's our factored form answer right here. It's like magic. So we could have changed our trinomial to a polynomial by writing those middle terms right there and then using factoring by grouping. But instead of doing that, I decided to go with this format, get the ax, the 6x, and the 6x, and get the pair of numbers from step 2 and put them right there, and then magically reduce each of these binomials by the greatest factor that you can, in this case 3, and in this case 2, giving us our final factored form answer. Okay? So it's really easy to apply. Now, the instructions said to write it completely factored, so let's not forget about this first original outside 3 that we had. Let's put that 3 out here in the front. So here's my factored form. Factored. Boom. What is it? It's 3 parentheses 2x minus 1 parentheses 3x plus 4. You will have to do some of these on the assessment Friday, and you're going to have to actually type them in with no spaces between any of the terms. All right? Now this was the very first one that you saw. There's a lot more that we're going to do. So we could go back to this one that we did factoring by grouping with, and we could try it with this new method. Let me actually pass out this little tiny slip of notes to you guys. Alrighty, so you should all have this little slip of paper right there that has the steps for you. And you have an example right here. We might as well start with this example. I don't know if you have enough space on this little tiny slip of paper. You might want to rewrite it, or maybe rewrite it on the back side and do the work. So let's begin with step 1. Step 1 is to do what? A times C. Right? Now, if we did have a GCF, like, oh, there's a multiple of 6. No, there's not a multiple of 6. If that would have been a 12, yeah, I could pull out a GCF of 6 from all 3 terms, right? So yeah, first try to pull out a GCF. But once you can't find, or there is no GCF, then you move on to other factoring methods. Maybe if this were a 9x squared and this were a 25, you'd be able to do square roots. But they're not perfect square terms. So we do have a number out here. We're going to go with that multi-step process. The first step is to multiply a times c, giving you what? A times c, that gives you a 36. Okay. Step 2 is to make a list of the multiples of 36. I always start with the number 1. 1 times 36, 2 times 18, 3 times what? 12, 4 times what? 9. 5 doesn't work. 6 times 6. Those are all the possible ways of multiplying numbers together to give you that answer 36. Question is, which pair of numbers combines, not multiplies, which pair of numbers combines together to give you the b value, in this case, minus 13, right? If I combine that, that'll give me 37. This will give me 20. This will give me 15. This will give me 13, right? 4 and 9 is 13. However, yeah, 4 plus 9 is 13, and we have a 13, but we want it to be a negative 13. So we have the right numbers, just the wrong signs. Change both of those signs to a negative 4 and a negative 9. Now we move on to the new stuff. Instead of changing it to a 4-term polynomial so I could then factor by grouping, instead of doing that, I want to jump right into my third step factored form format ax, and you know what? I'm going to write the ax up here instead of inside of the parentheses. And of course over here we have the number and the number from step 2. So what is my ax term? 6x, right? So everybody write down 6x. That's my ax term, 6x. Now how about the numbers that belong right here? -4 and -9. -4 and -9. And this was step 3, right? Step 3 up here. We wrote it in that format. We plugged in the a value with the x, a with the x, there it is. And we plugged in the pair of numbers from step 2 right there. Now step 4, the magic step, right? Magically reduce, bless you, magically reduce. Think of the GCF of each binomial if possible. So what could I reduce by on 6 and 4? What could I divide by on 6 and 4? 2. So if I divide that whole binomial by 2, and again I put this in a cloud because it's not really work that we're showing, we're doing this in our head, what do I end up with? 3x minus 2, right? And how about the other one? What could I reduce there by?
3.
Divide by 3, the whole thing. I put in a little cloud because that's not really math that we're doing. We're just doing it in our head. 6 divided by 3 is 2x minus 3. And guess what? We're done. You see, it's easy. So you don't really have to use factoring by grouping. You could use this magical shortcut method, right? It is written on the board right there. You'll have it to help you. You have the slip of paper right in front of you. And of course, you're going to become masters of this by practicing today. Now, let's say you're having second thoughts and you're not too sure, like, did I factor this right? Is this right? You're not too sure. You could distribute 3x times 2x. You know what? I'll just do that. Why not? Whoops. Why did that not attach? Not cool. Give me a second. Okay, so let's say you wanted to double check and see if you factored it right. Go ahead and distribute 3x times 2x at 6x squared. 3x times negative 3 is a negative 9x. Negative 2 times 2x is a negative 4x. Negative 2 times negative 3 is positive 6. Combine your middle terms. That'll give you a negative 13x with a 6x in the front, 6x squared in the front, and a plus 6 at the back. And that is what we originally started with. So now you're 100% confident that you did factor correctly. Yay? You don't have to do this check, but if you're ever in doubt, you could always distribute and combine like terms and see if you get to where you started with. Okay. Again, the whole purpose of factoring is to be able to get something like this to look like a multiplication problem. And why would we want that? Because if you had it equal to 0, and I told you to solve it, then you would have this factored form equal to 0, which means you could apply zero product property and split them and set them each equal to 0 and solve. In this case, your two answers, if it were an equation set equal to 0, your two answers would be x equals positive 2/3 and x equals positive 3/2. But that's probably something I'll explain later instead of right now. So once again, these are the steps. Hopefully we understand it, and we should be able to go to our page of notes and apply this shortcut method on many of these or on all of these questions that don't have the a value of 1. Okay, let's do this. Go to your page of notes. It's on the back side. Now, on the back side of our notes, it does say to solve this equation, practice, and it says use factoring by grouping. But we have a better method than factoring by grouping. We have this shortcut method. So again, we want to solve this. And how do we solve an equation that's set equal to 0 when there's two x's? We can't do it unless we factor it to get multiplication to be able to split them and solve using the zero product property. Okay, so the tip is to use factoring by grouping, but actually I don't want you to use factoring by grouping. I want you to use this beautiful shortcut method. Multi-step process, but let's use this shortcut method. Step 1 is to do what? A times C. Step 1, A times C. What is A times C? 2 times negative 3, which is negative 6. If you mess up right there, the whole thing's wrong. Okay? So yeah, it's negative 6. Step 2, make a list of the multiples of negative 6. Negative 1 times 6, negative 2 times 3, and that's about it besides changing signs. Now the question is, which pair of numbers combines together to give us the middle value, which happens to be positive 5? It's negative 1 and 6, not negative 2 and 3. If you combine these guys, that really does give you the b value, positive 5. If you combine these guys, it gives you a positive 1. That's not a positive 1, it's a positive 5. Right? So these are the pair of numbers that we want on step 2. Now step 3. Step 3, instead of changing it from 3 terms to 4 terms to use factoring by grouping, forget factoring by grouping, let's use the factored form format. The ax is the first term, and the numbers from step 2 are the second term. So the numbers from step 2, those are probably the easiest to write down right now. You have a minus 1 right there and a plus 6 right there. How about that ax term? Well, the a value is 2, and you put it with an x, so that would be a 2x right there and a 2x right there. Are you with me? Step 4 is to magically reduce, right? So step 4, what could we reduce that first binomial by? Nothing. So we just leave it. 2x minus 1. What could we reduce that second binomial by? 2. By 2. So if you reduce both the 2 and the 6, or divide both 2 and 6 by 2, what are we going to have?
X plus 3.
And guess what? We're done. Fun stuff, right? Easy peasy, lemon squeezy. Oh, wait a minute. We're not done. I'm sorry. I lied to you. Because right here, they're not asking us to factor. They want us to solve the equation. They actually want answers like x equals 5 and x equals something else. So this was an equation, right? This was an equation set equal to 0. We factored the left side, but it's still equal to 0. So let's just do this. Take this equals 0 and slap it right there. So here's our new equation that's in factored form. And why do we want a factored form equation that's equal to 0? Because we know zero product property. It says that if you have something times something else, and the answer is 0, the first something, 2x minus 1, that could be 0 itself, or the second something, x plus 3, that could be 0 itself. One or the other has to be 0, or maybe both of them are 0. So we set both of them equal to 0, and now we solve these two simple equations. This one I'm going to add 1. I'll end up with 2x equals 1. Final step, divide by 2. We have the answer x equals 1/2. The other one, subtract 3, x equals negative 3. So the two answers to this equation are x equals 1/2 and x equals negative 3. By the way, I might as well mention this on the quiz. You know how we type in our answers? I want you to type in answers with no spaces between your terms. So if this were a question on the quiz, I would like you to type in x equals 1/2, comma, x equals negative 3. So you would type it in like that with no spaces between your terms. Anyway, we are factoring to get multiplication to then use zero product property. By the way, there's going to be some ridiculously easy questions on the quiz, as easy as this. X minus 3, x plus 2 equals 0, and I'm going to ask you to solve it. What are the answers there? X equals positive 3, and x equals negative 2, right? I mean, you don't even have to really show the work here. I mean, you're supposed to say that this equals 0, that equals 0, solve both. It's going to be a positive 3 and a negative 2. So x equals positive 3, x equals negative 2. There will be some that are that ridiculously easy. Let's go back. Which one would you like to see? 2, 3, or 4?
4.
4 or 5? 4? Okay, 4. Always try to pull out a GCF first, which we can't, right? Yeah, it's an even number, odd number, even. We can't pull out a 2, can't pull out a 3, can't pull out a 6. We're stuck. So we actually need to go through the multi-step process. Step 1, multiply A times C. A times C is 120. All right. Ugly. Step 2, let's think of all the multiples of 120. 1 times 120. 2 times 60. 3 times 40. 4 times 30. 5 times, dang, 5 times what? 5 times 24. And you could use a calculator, right? You could go 120 divided by 5, you'll get the answer 24. 6 times, this is ugly, 20. 7, I don't think it's going to work. 8, that is 15. Okay. 9, it's not going to work. 10 times 12. Dang. All right. So which pair of numbers combines together to give us the middle value negative 23? So if we add 1 and 120, that's 121. That didn't work. That gives us 62. It doesn't work. 43 doesn't work. 34 doesn't work. 29 doesn't work. 26 doesn't work. 8 and 15, that does give us 23, but we want it to be a negative 23, so we have the right numbers, just the wrong signs. Change the signs. That's the pair of numbers that we want for step 2. We move on to step 3. Instead of changing our 3-term expression to a 4-term expression and using factoring by grouping, instead of that, I want to jump right in to my shortcut, which is going to be a ax, a number, ax, and a number. So what is our ax term? 6x. 6x right there, 6x right there. And what are the numbers? Well, you go to the step 2, which is the negative 8 and the negative 15. Plug in the negative 8 right there. Plug in the negative 15 over there. So negative 8 and negative 15. And the 4th step is that magic step to magically divide each binomial by its GCF. So the first binomial, we could divide both of them. Yes, we could divide by 2, right? And what do we get? 3x minus 4. And the second binomial, we could divide both of those by 3. And what do we get?
2x minus 5.
2x minus 5. And we're done. This is it. This is probably one of the hardest questions that there is. Right there. That's your factored form. Oh, no, wait. I'm sorry. It's equal to 0. So if they would have said factor, that would be your answer, to just factor it. But this is an equation that we need to solve. This is set equal to 0. So this is set equal to 0. And the whole purpose of getting a factored form is to have something times something equals 0, so you could split them and solve. So this first something could be set equal to 0. 3x minus 4, set that equal to 0. The second something, 2x minus 5, that's going to be set equal to 0. We're going to solve both of them. Plus 4, we end up with 3x equals 4. Then we're going to divide by 3, divide by 3. There's your answer, x equals 4/3. The other one, we're going to add 5. We're going to end up with 2x equals 5. Final step, divide by 2, x equals 5/2. So those are your 2 answers for this equation. What do you guys think? Do you get it? Do we need to see more? No. Okay. So the practice test is already available to you guys. Test is Friday.